Welcome. I want to go over a few kinematics tricks for you. So here we go. First thing, I strongly recommend you just list everything you know in the question. You got a word problem, it says a bunch of stuff, write down all the variables you know, label them. Remember, velocity comes in 4 flavors and you got to get it right which one it is. You got initial, which is like the velocity at the instant of the period of motion that you're looking at. So you can make that whatever you want. Just the velocity at a certain point, which is the beginning of the motion that you're looking at. You got final velocity, which is the end of the motion you're looking at. Something to be careful of there. Make sure there's a constant acceleration between the two, unless you're using a few very specific formulas, like average velocity is displacement over time. Because most of them only work assuming a constant acceleration. That's why we're always interested in the final velocity right before something hits the ground, because that lets the acceleration be 9.8 the whole time, rather than 9.8, 9.8, 9.8, and as soon as it hits the ground, some ridiculously high value up as the ground accelerates it up. So be careful with that. So that's 2, initial and final. We also have average velocity. So like on average, you're going so many meters every second. You can get that with displacement over time, or if you've got a constant acceleration, initial plus final over 2. You also have the last one, which is change in velocity, which we'll talk a bit about in a second. Anyway, so careful with that. Write down everything you know. Make sure you get your velocities right. The other thing you have to do is get the direction right. So in physics, since it's kind of hard to put up and down in a formula, all you got to do is if you got velocities or accelerations or whatever in opposite directions, you pick one direction to make positive and one direction to make negative. And it doesn't really matter which direction you decide is positive and which you decide is negative. Just don't screw it up. Got to make sure that everything up is whatever you said up was, and whatever anything down is in whatever direction down is. The most common thing to screw up with that is displacement. So if I say you throw something off a 20 meter tall building and it hits the ground so many seconds later, it's really common to be like, oh, it's a 20 meter high building that's that many meters up, but no. We're looking for displacement. What happened to the object? Did it go up or did it go down? So ask yourself that. In this case, we threw the object up, but it ended up further down than when it started. So if you've made down negative, make sure your displacement is negative, because it has gone down from where it started, so it's got to have whatever sign you assign to down, even though the question might phrase it as like a 20 meter tall building. But you're just interested in the motion of the object. Is it more up than it started or more down? And make sure it matches whatever you've decided here. And it's perfectly okay to always make up positive and down negative. Sometimes I switch it up. If everything's going to be down, I'll make down positive, but usually I'll use this standard. I also recommend you draw this out in questions, because it's just an extra reminder to, as you're labeling every bit of information you know, to get the sign right, because that can screw you up really good. That is the most common error. All right, so hopefully that makes sense. Write down everything you know, careful with your velocities, and careful with the sign of your displacement. Just ask yourself, did the thing end up further up or further down? Another common mistake, which you don't want to do, is using 9.8 for everything. You've got something slowing down horizontally. You're using an acceleration of 9.8. That's not true. 9.8 is only good if gravity is the only force on it. So if I throw something up and gravity is the only force on it, it has an acceleration of 9.8 if we're on Earth's surface. If something's rolling up a slope or anything, or just on the ground and sliding to a stop, gravity is not the only force on it, and it will not accelerate at 9.8. So do not use 9.8 unless it's just something flying through the air. That is the only time you want to use it. as the acceleration. So for a slope on Earth's surface, it should be somewhere between 9.8 and 0. 0 if it's perfectly flat, 9.8 if it's perfectly vertical, and something in between, anywhere in between. So careful with your use of 9.8. Remember, only use 9.8 if something is just flying through the air. At no other time is it 9.8. And it's on Earth's surface. Next trick. So when you are using this delightful formula here, and looking for, say, final velocity, you are going to have to take the square root, and your calculator will always give you a positive answer. Even though, like if you're in math class and you take the square root of 4, you've got two possible roots. You got plus and minus 2 without getting into imaginary numbers. So you actually have to use logic to decide, hey, what should my sign be anytime you take a square root? Do not take your calculator's word for it. Pick it intentionally. Like in this case here, just like before, we've got something on a 20-meter high building. We throw it up, and it falls to the ground sometime later, further down than when it started. If you were to solve for your final velocity and do your standard up is positive, down is negative, you were going to end up, your calculator would spit out a positive number, but that would imply it was moving up right before it hit the ground, which is probably not the case. So anytime you take the square root of any number, you got to use logic to decide, like, oh, I bet it was moving down right before it hit the ground. I've made down negative. I'm going to choose, even though my calculator says that my velocity should be 2, I'm going to make it negative 2 because I know it was moving down right before it hit the ground. So careful anytime you take the square root. Use your logic to decide on the sign, because that can get you completely the wrong answer if it's a two-step problem, rather than just it's negative when it should be positive, or vice versa. The next set of tricks, projectile motion. You're throwing something up or whatever like that, or rolling it up a slope and it comes back down. So some tricks, when an object reaches its maximum height, it stops for an instant before it comes back down. So it's moving up, up, slowing down, stops right as it's transitioning from moving up to moving down. So make sure you got that. It's an important thing. Also, if you throw something up in the air at 5 meters per second, when it comes back down to the same height, it will also be moving 5 meters per second, just down this time, which kind of makes sense because conservation of energy, which you learned last year, you got a bunch of kinetic energy. It's going to turn to a certain amount of potential, and then it'll turn into exactly the same amount of kinetic when it reaches the same height. So whatever its initial velocity is, if it's coming back down to the same height, it'll be exactly the same velocity, but down. It also takes exactly the same amount of time to go up as it does to come back down. So that can be really useful. Because a lot of times you're going to want to use half the time. It'll just make sense. If I tell you, you throw something up in the air and it comes back down 5 seconds later, then if I ask you how high did it go up, like if you try to use some sort of formula like this, it's not going to work because your displacement is 0. You know that, so that doesn't tell you how high it went if you're using the total motion. But if you're using half the motion, then the displacement for half the motion will be the max height. So you can use half the time for that. And yeah, so a lot of times it's going to be just better to use half the time, specifically the second half, because you got this lovely formula here, which has initial velocity and a t and a t squared, which is normally pretty hard to use together. You got a t term and a t squared term, but if vi is 0, like it is if you're just looking at this part of the motion, then it's a nice easy displacement is 1/2 at squared. And so if I told you it took 5 seconds to go up and come back down, and I asked you for the max height, if you're just looking at the second half of the motion, you just have to do 1/2 times 9.8 times half the time squared. So if it was 5 seconds to go up and down, it's just going to take 2.5 to come down. And that would give you your answer. Yeah. So you've got all these sorts of questions where you got to use these little tricks. It's 0 at the top. A lot of times you want to use half the motion, and it takes exactly the same amount of time to go up as it does to go down. And your velocity initially is the same as velocity final if it starts and stops at the same height. So know those tricks. Here they are. If you want to pause the video and just think about them for a sec. But if you know all this stuff and are halfway decent at your algebra and can use your formulas, you've got all the tricks now. You should be largely good to go. By the way, this might not be a terrible formula to add to your formula sheet. It is pretty useful and not on there by default. Hopefully this helped.